This is Chris.
Hello. So this is a bit of a risky talk, I think. Yesterday I was talking to one of the founders of Meteor, Matt, and he was talking to a group of us, and he said, you know, I think we ought to just start talking about some design decisions like fibers and how the event loop works, and no one will care, and it'll be really boring, but we should just do it. And I'm like, Matt, you know that's my talk tomorrow. It's on that subject. Should I change it maybe? And he was like, oh, no, go do it. It'll be great. So yeah, so that's basically the talk, and it's really intended for developers and for people who have been using the framework for a while. But I think to kind of get us started, it's amazing how much progress you can make with a framework like Meteor without really needing or knowing how the runtime works. And I think that's a good thing. I think that's a good thing, because you can get a lot done, and you can be sort of productive with getting your ideas translated into something quickly. But as you start to sort of build more complicated things, or you run into some debugging issues or things like that, it helps to have a better understanding of the underlying semantics, I think. And some of those concepts on the web are difficult to find. So if you've ever done a search for fibers, I did some research for this and tried to find something on like explaining the event loop and things like that. I had trouble. So I thought that's what we would talk about today. So to start us off with that, let's take a look. OK. The light, maybe? Yeah, kill the light, I think is the thing to do. So I want you to sort of close your eyes while we're killing the light. And I want you to imagine, we're going to just create a mental model here. And if this is already old news to you, I apologize. Just bear with me for about 5 minutes, and then we'll get to fibers eventually. Let's create a mental model for how the event loop works and what it means to be asynchronous. So I want you to close your eyes, or at least imagine that you're at San Francisco airport. And you're going to the airport, and you're a little bit late. So you're running to the security line. And now you get to the security line. And there's a bunch of bags. You pick one of these conveyor belts to have the X-ray scan your bags, right? And it's got a line. And you put your bags up on there. And then you wait into the last possible second to take your shoes off. And the reason for that is because you want to minimize the amount of time that your feet are on the ground, because that reduces the chance of getting a horrible disease. So you learn that here, which is a bonus. So as things are moving through this conveyor belt, it's one conveyor belt. There's only one thing that goes through this X-ray machine at a time. And if that X-ray machine stops, like for some reason someone leaves a water bottle or something in there, the conveyor belt is blocked. And so that's really the same thing as an event loop. I find it sort of weird to call it a loop, because as a mental model, that doesn't really make sense to me. So it's really a queue. And you're thinking of things that are going in a linear way through this queue. And sometimes it stops. Now, when sometimes something's in the X-ray machine, the guy will pull it off and will inspect it, because you left your water bottle or something in there, right? And they'll take it off, and they'll do some work that doesn't block the machine. So now the conveyor belt just keeps going, right? And more bags go through it. And so that work that's being done might be called parallel work, like, for example, when you're doing I/O. So I/O might be considered, I/O is something like you're opening a file, or you're making a network request. And when you're done doing that work, you might take the bag, and you might put it back onto the loop. You might put it back onto the conveyor belt. So it starts at the beginning of the line, and there's already stuff that's flowing through. So when it makes its way back to the front of the line, it'll go through the X-ray machine, and you'll continue. So I want to kind of, with that as our mental model for an event loop, go through and look at what does it mean to be asynchronous. And then we'll go and look at fibers. And if we have time, we'll look at bind environment, which is like the gold prize if you've been using Meteor for a while and you've gotten some errors that you don't know about with bind environment. So what we'll start off with is I've got a method here called X-ray machine, just to drive home the metaphor, although we'll try not to go too crazy with this. And I've just called this function 3 times, right? So with an index of 0, 1, and 2. And when that's done, I'm going to just print to the console that we're done with these 3 bags. We've processed the 3 bags, right? So if I go over and I run this, as you might expect, we see on the right there that we inspect bag 0, we inspect bag 1, and then we inspect bag 2. And then we print out that we're finished processing the 3 bags. OK, this will get a little more advanced pretty quickly here. So the next thing we want to do is just introduce the idea of what it means to be asynchronous, right? So I'm going to call this function called find. I've just called it find to make it somewhat similar to Mongo and the idea of something that makes a network call. But find is pretty silly. Find just takes a function like you might expect if you're using a node, just a regular node application. And the callback function, as a first parameter, takes an error, and as a second, a result. What I'm going to do is just print out the result. So keeping in mind this conveyor belt idea, when we call find, the idea of asynchronous means that we're going to put something back on the conveyor belt at a later time. That's all that really means. So in this case, we're simulating that by using a set timeout call. So the set timeout call says that in about 2 seconds, I want you to take this function or this bag and put it at the beginning of the line. It may not execute right away. It'll execute when it makes its way to the X-ray. So this would be the same thing as if you made an I/O call, like you went to Node.js and you said, open this file. And Node will say, OK, I'm going to delegate that to the operating system. And when it's done, I'm going to take this function, put it at the beginning of the line, and when it gets to the X-ray, it'll execute. So that's what it means to be asynchronous. So using JavaScript is pretty cool because we can take these functions and we can pass them around. And we can call a function at a later time once we've done some work. So in this case, it's not parallel. We're just setting a timeout and saying do this at a later time. But the same kind of function works for I/O. OK. Now what we're doing here is oftentimes we want to wait for the result. So I'm going to run this function. And as you would expect, one of the main highlights of this part of the presentation was this frightening result, but I forgot to mention it. So because it's Halloween, the result we're getting is frightening. I want you to really notice that. It took me a long time to think of that. So what this is going to do is it's going to process these 3 items first. So it's going to go inspecting bag 0, inspecting bag 1, inspecting bag 2. And then at a later time, at about 2 seconds later, we'll get these 3 results almost at the same time, because they go through very quickly, right? And so that's why we see that we're done processing the 3 bags, and then at a later time, we get this frightening, ghoulish result. Now, most of the time, we want to just wait for the result, because there's nothing else we can do until we have the result, like when we make a database call. So we use this callback mechanism to wait. But if I put something down here just to sort of drive home the point, as you know, this will execute right away, right? Because we're not waiting. So we inspect bag 0, and then we call after, and then inspect bag 1, and then after, inspect bag 2, after. And then about 2 seconds later, we get our result. So what we can do is, we'd like to really be able to write this in what's called a synchronous style. And so this is a design decision that Meteor made, which I believe is a good one, which allows us to write something in a synchronous style without actually blocking the entire event loop. And I'm going to show you what that means. So let's say instead of writing find with function error result, and we just want to wait on the result. And then I just want to print it. This code looks a little bit nicer. It's a little easier to read, right? So what I want to be able to do is to wait until I actually have a result, and then I'll print it out here. But the goal is to be able to do this without actually blocking the conveyor belt. So we can use something called fibers to do this. And I found fibers to be a little bit counterintuitive. So let's just go through the example. So I've included fibers up at the top by just requiring fibers. This is just a regular Node application, by the way, nothing Meteor specific here yet. And what I can do is create a new fiber by just calling fiber here. And the first thing you'll note is that a fiber basically just wraps a function. And then we can run this fiber. And the cool thing about fibers is that in the middle of their execution, we can pause them. and just pause that one function and let other functions that are on the event loop continue to execute. And so to do that, let's go in and change this find method a little bit. We're still going to use setTimeout to simulate an asynchronous function, something that puts something back onto the event loop at a later time. But this time what we're going to do is we'll get a reference to the current fiber. And I'm going to create a variable called result and assign it equal to fiber.yield. And inside of the timeout, I think it's run. We'll see. Ghoulish result this time. OK. So what we're doing is we're getting a reference to the current fiber, if there is one, using this global fiber.current. And then we're yielding the fiber. It's kind of a strange term. What it means is just pause this current fiber. But what is that? It's just this function. It's not anything else outside of it. So we're not actually blocking anything. We're not blocking the event loop. So let's run this just to get a more intuitive sense of what's happening. I bet like 3 people have probably spotted errors already, but we'll run, and then we'll debug. Undefined. Oh, because we don't actually return the result. Right? OK. So what I expect to happen here is that the output is the same as what we had before. So using the callback style, right? So we expect back 0, 1, and 2. And then later, when we have a result, we print out that result. And this time, ghoulish instead of frightening. But we wrote this code in a synchronous style, which was just basically easier to read. So that's how basically fibers work, and one of the key benefits they give us. Another benefit is actually it gives us the ability to attach variables to it, because a fiber is actually an object, right, that we can run and resume and do things with. And so let me demonstrate that. So how much time do we have left? 8 minutes. Oh, man, I'm going like a bat out of hell. OK. How many people in the room, before I jump into this, it might be too esoteric. So let me just check. How many people have been using Meteor for more than 4 months? OK, and how many people have run into this, your code must be run inside of a fiber? Should I ask how many people know what it means? Or let's find out what it means, OK? OK, so that's a very confusing error. And I think like what we generally do to fix that is we put it inside of a fiber, and it goes away. And that is the right thing to do most of the time. But you might want to have a little bit more intuition as to what actually is happening. And so I'm going to give you that intuition now, hopefully. So we're creating this fiber to run our code in. And we know that now fibers can yield, which it basically means just pause this current function, but let other functions run. Just pause this one. Well, one thing we might want to do is we might want to create a global variable that's accessible to to functions that are running. We might just want to have like a global variable out here that says like index. And the reason for having that global variable is maybe I just don't want to pass it around, right? Like I might not want to take this index here and pass it to this print function. I want the print function just to be able to get access to that index variable somehow without it affecting my method signatures. But the problem is I can have lots of fibers, and they can be yielding all the time. And so I need a way to attach a global variable to the fiber and to keep that variable attached to the fiber so that if it gets resumed, I have access to the right value of that variable. So what I can do is create an environment variable, a Meteor environment variable. I'm going to go a little bit quicker than I did before here. I've actually pulled out the relevant Meteor code into its own file and eliminated the dependencies just so that we can look at specifically what this is doing. And that's what this require dynamics node is. So what I'm going to do is up here, I'm just going to create a variable that's global. And I'm going to call it, like, I don't know, current index. How about that? And set it equal to just a new environment variable. And what I can do with that is I can say current index.with value. And this is how I set the value of current index. And then as a second parameter, I'll pass a function. And we'll just paste in this stuff here. Now in my print function, I might change the signature a bit so that it doesn't have to take this index anymore. it'll just grab the index from the global, the global variable. Just bear with me for 1 second. OK, so I'm going to override the print function. And this time, instead of getting the index, which was just a helper, a number there for printing, as you can see over on the right, what I'm going to do is I'm going to grab that from this global variable store. And the way I'll do it is to say current index dot get. It'd be helpful if I assigned it to something. And then I'll just get rid of it as a parameter. OK, so now I haven't had to actually create a method signature now for the index. It's just part of sort of the global environment that's available. And I grab whatever the current value is, and I use that. So now what I can do is run the function and pray. See what happens. Great. So we still get the indexes printed. You can see the 0, 1, 2, right? Now what happens if I just sort of get rid of this fiber? Yeah, I think this is probably the right way to do it, right here. And now we get this error message. And the error message says that Meteor code always has to be run in a fiber. And the reason for that is because this global environment variable, the way that it's called Meteor Dynamics works, is it takes this and it attaches it to the fiber. And so when it goes to retrieve it, if there's no fiber, currently running fiber, it has nothing to retrieve it from. And so it detects this condition, and it says, if you're not currently in a fiber, there's no way for us to grab the global environment variables for that. So a little bit esoteric, but the reason that this is important is because that's where we put Meteor puts things like your method invocation that contains the current user, for example, or the write fence that's used to track how many writes have been committed. So what you can do if you want to learn more is you can go and go into the Meteor package, and it's in the Node.js or dynamics_Node.js file. And you can see it's not very complicated, but where that error comes from. So hopefully this gave you, one, a better idea of what it means to be asynchronous, especially if you were new to Node or to an evented system. And then we looked at what fibers are and how Meteor uses them, and then why you're getting the error that says that your code must be run inside of a fiber by using global environment variables. So a little bit down in the weeds, but hopefully it was a little bit enlightening. And that's all I've got. So if people have any questions, I'm happy to answer them. I apologize to the non-coders in the room. Sure.
You mentioned bind environment.
Oh, yeah. Yeah, so, right. So what does bind environment actually do? So bind environment, if you're familiar with a closure, where you say, I want to take like the current value of all those global variables and just save them. So when you call bind environment, it says, what are all the current values? The variables are dynamically scoped. We don't have time to talk about that, I guess. But what it means is they could change as you go up the call stack. So it saves them all. And then when in your callback function, if it's not already running in a fiber, it will create one and make sure that when it creates it, it copies over all those global variables to the new fiber. I think showing an example would probably be the best way to see it. If you don't call bind environment, well, let's put it this way. If you call set timeout, for example, and you don't need any of those global variables, like you're not making any Mongo calls or something, then it doesn't matter. You don't need it. But if you want to save away like the write fence or something like that, and you have a callback that runs later, you need to somehow copy over those global variables to the new fiber once it gets created. Does that make sense?
Once the fiber is done, do all those variables are they in their original versions? Is it basically like a copy, like a by value kind of thing?
Mm-hmm.
Got it.
Well, by value, yeah, yeah. All right, yeah.
So it seems like this fiber's method of writing Node server-side code makes it a little easier to digest, and it's nicer syntactically. Are there any pitfalls of using this? Like, does it make testing harder, or does it make anything less pleasant?
So the question was, are there pitfalls to using fibers? And your example was in testing and other things. I mean, I think the biggest pitfall is that most of the Node libraries are not written this way. And so It makes working with NPM packages a little bit tricky, but really it's not too bad. There's a facility to wrap them. I think it's just not well documented yet. So I've done a few videos, for example, on Evented Mind, where you can go and see how to do it. It's 10 minutes. So, but that's the biggest pitfall. In terms of performance, a lot of the big misconception is that there's some kind of performance penalty. If there is, I don't know what it is, because it's just basically a syntactic change. So, any other questions? Yeah.
So you say you can have like lots of fibers.
Yeah.
So are there like multiple different, I guess, queues you can have at one time? How easy are those to manage?
So I'm glad for that sign. Otherwise, I definitely would not repeat the audience question. The question was, can you have multiple queues? And so you're talking about the airport conveyor belt where you put your shoes?
Right.
Is that the, yeah. So think of that as like one-to-one with a Meteor process and with one CPU. And so there's one set of instructions being executed. You have access to one CPU. It's one process. So if you want 2 lines, you need 2 processes. And so you would create 2 Meteor processes or 2 node processes, right? Does that answer the question?
Yeah.
OK.
So are fibers in any way multi-threaded or scheming up these other processes?
No. Node.
Single-threaded the whole way through.
Oh, sorry, right. So the question is it single-threaded? And this was actually I don't know if it's a mistake, but I'm going to call it a mistake in the documentation where it says that each request is handled in its own thread. I think that it was a little ambiguous. So it's not a thread in the sense of the operating system thread. A node is single-threaded, right? So it's one process, one thread. But fibers sort of act similar to a thread in the fact that they can yield. But the operating system is not randomly going to swap them in and out and schedule them for you. The user decides when it's time to yield. So it's single thread, single process. Other questions? Thanks for your time. I hope it was helpful.